So we have seen different components of Crew, that is process, agent, task, tool, and memory, right? And we built multi-agentic applications by using this CrewAI, right? Now let's go to VS Code and see another application. So far we have seen one of the scenario, web scraping and extracting the text and then creating the agent and task and running the crew and retrieving the desired results. And then we have seen another application where the agents were able to generate the personalized email drafts, right? So now let's see another use case number 3. So let me go to tools and agents demo and file, new file and Python file, and let me save this as CrewAI use case 3 trading platform and click save. So let's see how we can build the complete stock trading platform project demo by using CrewAI. Okay, so the first thing is we need to install all the required packages before we start building the application. And we know we have to install CrewAI and also CrewAI tools. In case if you haven't installed already, make sure you install these two packages by going to the terminal and giving this command and hit enter. So that way these two packages will be installed. And for this application, we also need tokenizers. This is the latest version of tokenizers we need. In case if you haven't installed already, make sure to install this latest version of the tokenizers as well. So I will explain why we need these packages, right, when we start using them. And the next step is we have to import all the required modules from these packages. So here we are trying to import agent, task, and crew classes from CrewAI package, and then scrape website tool, Serper dev tool from CrewAI tools, and crew and process from CrewAI, and then chat OpenAI from LangChain OpenAI. We will be using OpenAI as our LLM, and then load.env from .env and OS module. So these are the required modules that we need. And once we imported all the modules, now let's try to set the API keys, and you need to store these API keys inside this environment file and read that inside our code. I've already shown you how to store the environment variables inside this environment file. So let's try to load the environment variables from this .env file by using load_.env function, which is from .env package. And the next thing is let's try to read the API keys once we load the environment variables from this environment file. So we have stored our OpenAI API key and also Serper API key. These two are stored inside this environment file. So this is the name and the value we have stored inside this. So by using this OS module and using the getEnv function, we are passing the name, so we will get the value. So that is how we read both OpenAI API key and also Serper API key. Let's try to store these two API keys inside the environment variables, OpenAI API key and also Serper API key. And here we will be using both scrape website tool and Serper dev tool. So let's try to instantiate both these tools. So Serper dev tool is our search tool, and to scrape the website we will be using scrape website tool. So let's instantiate that as well. So here Serper dev tool is the search tool, so we are assigning to this variable, and scrape website tool is used to scrape the website. So these two tools we are using them from the CrewAI tools. One is the search tool and the other one is the scrape tool. We have already seen how to get the API key for Serper dev tool in the previous lecture. So make sure you get the key and store it inside the environment variables and then read the API keys here. Okay. Instead of using Serper dev as our search tool, in case if you want to use any other open source tool like DuckDuckGo, you are welcome to use that as well, right? So you don't have to use just the Serper dev tool. You can explore any other tools also. And let me close this. So far we have installed all the required packages, and then we loaded the modules, and then we read the API keys, and then we stored inside our environment variables both OpenAI API key and also Serper API key, and then we instantiated both tools from CrewAI tools. One is the separate dev tool, that is the search tool, and then the next one is the scrape website tool, right? And now by using this agent, task and crew classes, let's try to create agent, task and crew, right? So the first thing is, in order to build the multi-agentic framework, we need to create the agents. So let's try to define an agent by instantiating this agent class, which is from CrewAI. So here we are trying to define the data analyst agent. Here we are instantiating this agent class and we are setting these parameters. For role, we are setting as data analyst. And what is the goal of this agent? Monitor and analyze market data in real time to identify trends and predict market movements. And what is the backstory? Specializing in financial markets, this agent uses statistical modeling and machine learning to provide crucial insights. With a knack for data, the data analyst agent is the cornerstone for informing trading decisions, and verbose is equal to true. So that means we want to see the complete execution log whenever this agent is trying to perform any task. And allow delegation is equal to true. So that means the agents will try to delegate the task with another agents, and tools is equal to, here we are passing the tools as a list. So we are using both scrape tool and also search tool. So this is how we created data analyst agent. So that is our agent number 1. So you know, role, goal and backstory, these three are nothing but prompt engineering, right? So here we are trying to provide the context, right? So we are saying, as a data analyst, your goal is this and this is your backstory, right? So that is, we are trying to provide more backstory or context, right? So these three things, role, goal and backstory, are mandatory whenever we are trying to create an agent, and verbose is optional, and allow delegation, that is to delegate to other agents, and the default value is false, but we are trying to set it as true. So the agents can delegate the tasks to another agents, right? And we haven't written memory here, but the default value of memory is true, right? But the objective of this agent is just to collect the data. We don't need memory anyways here, right? And we have specified these tools as well, both scrape and search tool. So with this agent, the data analyst agent, has tools, memory, and we will assign the task as well, right? So the agent will know what to do. So this is one agent which does data collection, right? And now let's create another agent, agent number 2. So this is the trading strategy developer. The first one is data analyst. The second one is trading strategy developer. And what is the goal? Develop and test various trading strategies based on insights from the data analyst agent. So the data analyst will give you the report, and based on the insights, you give us the trading strategies. So this one will give us the insights and this one will give us the trading strategies. And what is the backstory? Equipped with a deep understanding of financial markets and quantitative analysis, this agent devises and refines trading strategies. It evaluates the performance of different approaches to determine the most profitable and risk-averse options. And verbose is equal to true, allow delegation is equal to true. And again, we are passing scrape tool and search tool as our tools, right? So this is the trading strategy developer agent. So far we have created 2 agents, and this trading strategy agent is dependent on data analyst agent, because first the data analyst agent has to analyze the data and identify the trends, and then the role of trading strategy developer is to develop the trading strategies based on the insights from data analyst agent. So this agent is dependent on this agent, right? So these 2 agents have to work in sequential order. That is, the output of data analyst agent will be the input to trading strategy agent, right? And this process is nothing but sequential. So the objective of data analyst agent is to identify trends and predict market movements, and the objective of trading strategy agent is to create the strategy, right? So far we have created 2 agents, and now let's create another agent So let's try to define the third agent. This is trade advisor agent. So what is the role, goal, and backstory of this advisor agent? The role is trade advisor. What is the goal? Suggest optimal trade execution strategies based on approved trading strategies. So we will get these trading strategies from trading strategy agent. So once we get the trading strategies, the role of this trade advisor agent is this agent specializes in analyzing the timing, price, and logistical details of potential trades. By evaluating these factors, it provides well-founded suggestions for when and how trades should be executed to maximize efficiency and adherence to strategy. And verbose is equal to true. We want to see the complete execution log, and also allow delegation is equal to true, and we will be using these two tools when executing this task, right? So far we have created three agents. Agent number 1 is for the data collection, and agent number 2 is to develop the trading strategy, and agent number 3 acts as a trading advisor, that is to recommend when and how to trade, right? So far we have created three agents, and now let's try to create the fourth agent, that is the risk assessment agent. So this is our agent number 4. And what is the role? Risk advisor. And what is the goal? Evaluate and provide insights on the risks associated with the potential trading activities. And what is the backstory? Armed with a deep understanding of risk assessment models and market dynamics, this agent scrutinizes the potential risks of proposed trades. It offers a detailed analysis of risk exposure and suggests safeguards to ensure that trading activities align with the firm's risk tolerance. And verbose is equal to true, allow delegation is equal to true, and again tools, we are using scrape tool and search tool. So far we have defined 4 agents, starting from collecting the real-time data to getting suggestions of which stock to buy and analyzing the risk in case if you buy those stocks, right? The next thing is we have to assign tasks to all these 4 agents, right? So let's try to create the tasks. Okay. And now for these 4 agents, the first one is data analyst agent. So let's try to create the task for this data analyst agent. So we are instantiating this task class, which is from CrewAI, and we are setting these parameters. For description, continuously monitor and analyze market data for the selected stock. This is the dynamic variable. We will be passing the stock name, so that will be replaced here. Use statistical modeling and machine learning to identify trends and predict market movements. So that is the description of this task. And what is the expected output? Insights and alerts about significant market opportunities or threats for the particular stock name, right? And we are assigning this task to data analyst agent, right? So that is our task number 1, which is assigned to data analyst agent. Okay. So here we are not hard coding the stock name. Instead, we are trying to just build a generic trading framework. So you can use this for any stock. It is not just for one stock. You can assign any stock value to this stock selection variable, right? And instead of these prompts, you can replace with any other prompts as well. So you can see the desired output. And also make sure you are providing the correct agent name. Whatever you have defined here, you have to provide the same name for this agent parameter. All right. So now similarly, what is the second agent? Trading strategy agent. So now let's try to create a task for this agent and assign it to this. So that is our task number 2. So here we again instantiated this task class and we are setting these parameters. And what is the description of this strategy development task? Develop and refine trading strategies based on the insights from the data analyst, right? And user defined risk tolerance. We will pass these value, and this is a dynamic variable again. Consider trading preferences. So we will pass the trading strategy preference as well. And what is the expected output of this task? A set of potential trading strategies for the stock name that aligns with the user's risk tolerance. And what is the agent? We want trading strategy agent to perform this task and give us the expected output. Okay. And similarly for the third agent, which is nothing but execution agent. So that is the trade advisor. We need to assign the task. So let's try to create the task and assign that to execution agent. So here again we instantiated this task class and we are setting these values. And what is the description of this task? Analyze approved trading strategies to determine the best execution methods. So we will get these trading strategies from the second agent, right? The output of the second agent is trading strategies. The output of the first agent is to provide the insights. The output of the second agent is to give us the trading strategies. So what is this task doing? Analyze approved trading strategies to determine the best execution methods for the stock. Consider current market conditions and optimal pricing. And what is the output we want? Detailed execution plans suggesting how and when to execute trades for this stock, right? And we are assigning this to execution agent, that is agent number 3, and this is the task number 3. So similarly, for the last agent, which is risk advisor agent, let's try to create a task. So that is our task number 4. And what is the description? Evaluate the risks associated with proposed trading strategies and execution plans for the stock. Provide a detailed analysis of potential risks and suggest mitigation strategies, right? And what is the expected output of this task? A comprehensive risk analysis report detailing potential risks and mitigation recommendations for the corresponding stock. And we are assigning this to risk management agent. So far we have created 4 agents and we defined 4 tasks. And we assign these 4 tasks to 4 agents, right? And the next step is creating the crew. So let's try to define the crew with these 4 agents and 4 tasks, right? So this is our crew. We are instantiating this crew class and we are setting agents, tasks, manager LLM, process and verbose. For agents, we are passing these 4 agents that we have created as a list: data analyst agent, trading strategy agent, execution agent and risk management agent, right? So this is the agents list. And the next one is tasks list. Whatever the tasks that we have created, we are passing them as a list. And this is the manager LLM. So for the LLM, we are using OpenAI, and this is the model we are using, GPT 3.5 Turbo, and temperature is equal to 0.7, and process is equal to, we are following the hierarchical process. So that means it is not sequential, right? So the manager LLM, that will need to approve before you buy any stock, right? And all the agent results will be approved by this LLM. So that is why we are using this manager LLM. And the process class, this one, we have imported from CrewAI, right? So this process class helps to delegate the workflow to the agents. So it is kind of a manager at work, right? So in this example, it is hierarchical process. So we have created the crew. And now, before we run the crew, here we are setting few dynamic variables, right? The stock selection and risk tolerance, trading strategy preference. For all these dynamic variables, let's try to set the input data. So this is our example data for kicking off the process, right? Financial trading inputs, these are the values, name value pair. For the stock selection, we are using Apple as our stock. Here, instead of this, you can replace with any other values. And this is the initial capital, and risk tolerance is medium, and the trading strategy preference is day trading, and news impact consideration is true, right? So this is our input data. And now let's run the crew. So to run the crew, we know inside this crew we have a method called kickoff. So let's try to run the crew by calling the kickoff method and passing this input value. And the inputs is equal to financial trading inputs, which we have defined here. Now let's try to print the results. The final result is equal to, which is stored inside this result variable. So we are just trying to print the results here, right? And in case if you want to display the final result as markdown, so we can do that as well. So we are just trying to give the file name as output.md. So this is the name of the markdown file. So we are trying to store inside this downloads folder, and the file name is output.md. That is a markdown file, and we are just trying to store this result and writing that to this file, right? So with this you are able to see the results in the terminal, and also we are writing the content to this output.md, that is a markdown file. Okay, and let's just try to print. The markdown content has been saved to this file name. And what is the file name? Output.md, and we are storing that inside downloads folder. So now with this we built the multi-agentic framework. Now let's try to run this code and see if it is generating the output. So let's click on run. So you can see the crew execution started, and the crew manager started as well, and the agent also started the task, and the agent data analyst agent is trying to perform the task. So it is trying to analyze the market data. So it is trying to crawl different websites and trying to give us the real-time data. And then the next one is trading strategy developer, that is in progress. That is the agent number 2, and it is completed. And now the crew manager is evaluating the risks, and the crew manager is in progress. The execution completed, and this is the final result. Apple faces significant regulatory and legal risks threatening its high margin services segment, with potential commission cuts impacting profitability. The China heavy supply chain and political pressure to move manufacturing to the US create major macro headwinds and margin risks for Apple. Lack of innovation, slow R&D growth, and delayed AI adoption further weaken Apple's investment case compared to other mega cap techs. Despite a lower share price, Apple's valuation and growth outlook do not justify a buy. A selling rate is maintained for Apple. Markdown content has been saved to this file, right? So we are trying to store the result inside this downloads folder. So this is our output.md, which is nothing but the same result we are storing inside this file, right? Let's try to go through this output. Since we gave where pose is equal to true, we are trying to see the complete execution log. So here you can see the crew execution started, and the crew manager is in progress, and the first agent is data analyst. It is trying to gather current market data for the Apple stock, including historical prices, trading volume, and financial reports. So it is trying to crawl different websites, for example Yahoo Finance, right? And it crawled hundreds of websites here. So you can see investor.apple.com, wsj.com, that is the Wall Street Journal. It is trying to crawl different websites and gather the real-time data. So that is our data analyst agent, and it is giving the final answer. And this is the analysis that it has provided. And then the crew manager is trying to ensure that the team gathers the necessary market data, right? So the crew manager is kind of a manager where it checks the output of each agent before it approves, right? So the agent started and it crawled to different websites and it collected the real-time data. So the output generated by the agents will be evaluated by the crew manager, right? And once the data analyst completes the execution, the next one is preparing the trading strategy by using trading strategy developer, right? I need to gather the most recent data and analysis for Apple to provide a comprehensive assessment of significant market opportunities or threats, right? So that is the task of trading strategy developer, to develop a trading strategy, and it is trying to execute, and this is the final answer for trading strategy developer. So it provided this strategy, right? And then again the crew manager is trying to evaluate, and then the task is completed. And it also analyzes the risk, and it is finally giving us the output, right? So here you can see risks of trading strategies for Apple. So it is trying to evaluate the risks also. Once it analyzed everything, it is trying to give us the final answer whether to buy Apple stock or not, right? And the crew execution completed, and it is giving the final output, and we are also storing that inside this output as markdown file. So you can see, instead of we searching hundreds of pages and trying to analyze the data and understand the risks, we built in multi-agentic framework, and we were able to get the final insight, right? So if you want to go through these websites and trying to understand the results, it might take time, right? So instead of that, we built an agent and we provided the context and we got the analysis of the stock, right? So you do not have to do these tasks manually, right? And the agents are doing it for us. So this is how you can build a stock trading project by using CrewAI, right? So we want suggestions and risks as the output, and which we got from this CrewAI, right? So agents are searching hundreds of pages and providing you with trading insights, right? So which is cool. So now let me close this and let's quickly review what we have learned here. So the first thing is we installed the required packages, that is CrewAI, CrewAI tools and tokenizers. And the next thing is we imported these modules from CrewAI, CrewAI tools and LangChain OpenAI. Here we are using OpenAI as our LLM, and these are to load the environment variables, right? So we read the API keys and we stored inside these environment variables. And then the next step is here we instantiated our search tool. We are using SerperDev as our search tool and Scrape website tool as our scrape tool, because it is trying to crawl different websites. As we saw in the output, it tried to crawl hundreds of websites and provide us the results for Apple stock, right? So that is why we are using this search tool also. And then here we defined 4 agents. The first one is data analyst agent to identify market trends, right? And then the next agent is trading strategy agent to develop the trading strategy based on the insights from this data analyst agent. And then the third agent is trade advisor agent. It is to advise the trades based on the trading strategy that the agent developed before. And the fourth agent is risk advisor. So this will provide any insights on the risks with the trading activities, right? And then for these 4 agents, we have defined the 4 tasks, what each agent should do. So this is nothing but prompt engineering, right? So we have defined 4 tasks and assigned to each agent, right? So once we created the tasks and agents, the next step is creating the crew. So here we created the crew by instantiating this crew class, and we passed agents, tasks and manager LLM. For the LLM, we are using OpenAI GPT 3.5 Turbo, and the process is hierarchical, right? Because the manager LLM has to approve, right? So that is why we are using this hierarchical process, and verbose is equal to true. We want to see the complete execution log, and here we define the input data. Instead of Apple, you can replace this with any other stock, right? And then inside crew, we have the method called kickoff. For this method, we are passing our input data as value to this inputs attribute, and we get the final result, right? And here we are trying to just write the content from this result to this file. This is the markdown file, right? So this is how we are able to build a multi-agentic stock trading platform project by using CrewAI. All right. Thank you.